Good evening, students. Welcome back to my channel. Today we are going to discuss the topic mensuration. Mensuration means measurements. In mathematics, mensuration means measuring the area, perimeter, and volume of some geometrical figures. That means here we have to define the area and perimeter and volume of some geometrical figures. In the case of two-dimensional shape, 2D shape, we have to discuss the area and perimeter only, and in the case of 3D shape, we have to define area, perimeter, and volume also. First, we have to define what is perimeter. Perimeter is the total length of the geometrical figures. Next, what about area? Area is how much space occupied for placing the geometrical figures. That means here we have to considering one string. What about the perimeter of the string? It is the total length of the given string. Next, we have to folding this string into a closed figure. Therefore, here we have to find out the area. That means how much space is occupied for placing this, that is area of this string. That means this region. This region is denoting the area. Therefore, let us considering the perimeter of a rectangle. How can we find out the perimeter of a rectangle? Consider a rectangle. Rectangle here, the opposite sides are equal. Let us consider the rectangle ABCD. Here DC and AB are equal. Let us take DC equal to L centimeter and AB is also L centimeter. BC is equal to B centimeter. Then AD is also B centimeter. Here the opposite sides are equal. Next, we have to find out the perimeter of the rectangle. How can we find out here? We have to find out the total length of this rectangle. That is, here we have to add all sides. That is AB plus BC plus CD plus AD. The perimeter of the rectangle is equal to L plus B plus B. That is equal to 2L plus 2B. That is equal to 2 into L plus B. Therefore, the perimeter of the rectangle is 2 into L plus B. Next, we have to find out the area of the rectangle. We know that area is equal to length into breadth. Therefore, area of the rectangle is equal to length into breadth. In this rectangle, length L centimeter and breadth B centimeter. Therefore, in rectangle ABCD, length is L centimeter and breadth is B centimeter. Therefore, the area is equal to L into B. Next, let us consider square. In the case of square, we know that all sides are equal. Let us take one side is A centimeter. Therefore, here all sides are A centimeter. Therefore, the perimeter of the square is equal to, perimeter is total length of the figure, that is perimeter of a square. Therefore, the perimeter of the square equal to adding all sides A plus, a length of the all side is adding length of all sides that is equal to a plus a plus a, that is equal to 4a. Next, find out the area of the square. Then area of the square, here area of the square equal to side into side. Each side is a, therefore side into side it is equal to a into a, that is equal to a square. Next we have to consider triangle. We know that triangle has three sides. Each side is taken as S1, S2 and S3. Then the perimeter of the triangle is equal to S1 plus S2 plus S3. We have to add all these three sides. And area of the triangle. Area of the triangle is equal to, here we have to draw a perpendicular line. It is the height of the triangle. It is denoted by h. Therefore, the area of the triangle is half into base into height. That is half into bh. B into, here the base is b. Therefore, half b into h. Next, we have to consider a circle. In the case of circle, we know that circle has center and it makes an equal distance from the all points of the circle. Here we have to draw a line segment from center to each point of the circle is called radius. Here O is the center and OP is the radius of the circle. In the case of circle with the center O and radius R, here the perimeter of the circle is equal to, we know that in a complete rotation it is 2 pi. Therefore, equal distance, here we have to draw a circle with equal distance R. Here completing one rotation, the total length of this rotation is 2 pi into R. Therefore, the total length of the circle is equal to 2 pi R. And area of the circle. Area of the circle equal to, here we have to cut the circle into two semicircle. We will draw many radius. Then after that, we have to take each semicircle. In a layer, we have to take each semicircles, this circle into two equal parts, that is two, it will be two semicircle and it will be pasted this manner. Therefore, we will get a rectangle. That means here the length is half of perimeter. Here perimeter is 2 pi r, therefore the length is half of perimeter. This one is the length, therefore half of perimeter, that is half of 2 pi r equal to pi r. Therefore pi r is the length and here the breadth is radius r. Therefore area of the circle is pi r into r, that is equal to pi r square. Next we have to considering this type of question. Consider a rectangular region. Inside path can be plotted. Then how can we find out the area of this region? How can we find out the area of this region? First we have to find out the area of the total region, that is area of the rectangle A, B, C, D, and finally we have to find out the innermost region. Here will be a rectangular form E, F, G, H. That is, here we have to find out area of the shaded region equal to area of rectangle ABCD minus area of rectangle EFGH. Then finally we will get the area of this shaded region. Next, let us consider a circular playground. Inside this circular region, we have to find out the area of and another two rectangular region. Grass ground is there. These are two rectangular grass ground. Then how can we find out the area of this shaded region? Remaining region. How can we find out the area of this remaining region? How can we find out the area of the shaded region? Area of the shaded region equal to area of the circle. First we have to find out the total area of the circle minus area of the first grass ground minus area of the second, that is first grass ground and second grass ground. Area of the second grass ground, we will get the area of this shaded region. Next, we have to define in the case of parallelogram. What is parallelogram? Parallelogram is a quadrilateral. It has four sides, four angles, and four vertices. Both pair of opposite sides are parallel and equal. That is, in this case of parallelogram, both pairs of opposite sides are parallel and equal. Let us consider the parallelogram ABCD. Here we have to considering DC as B, that is base B. Then AB is also B centimeter. Then BC is considering as a side, it will be taken as S. Then AD is also S. Therefore, the perimeter means total length of the given polygon. Now here a parallelogram is a polygon or it is a geometrical figure. Therefore, perimeter is equal to adding all these sides. Therefore, AB plus BC plus CD plus AD. AB plus BC plus CD plus AD. That's equal to, here AB is equal to B plus BC equal to S plus CD equal to B plus AD equal to S. That is equal to B plus B, 2B plus S 2S. That is equal to 2 into B plus S or S plus B. Next, find out the area of the parallelogram. Area of the parallelogram. Consider the parallelogram ABCD. Here B as the base and H is the height. Therefore, how can we find out the area? Here area is equal to base into height. That is equal to, here base is B, B into H. Therefore, area of the parallelogram is base into height. Next, let us consider another quadrilateral trapezium. Trapezium is a quadrilateral in which one pair of opposite sides is parallel and other pair is non-parallel. It is a quadrilateral in which one pair of opposite sides are parallel and other pair is non-parallel. That is, consider a trapezium ABCD or consider a trapezium ABCD. Here one pair of opposite sides are parallel. Here AB parallel to DC and AD not parallel to DC. Here we know that area of a parallelogram is base into height. By using this area, we have to find out the area of the trapezium. Next, consider another trapezium joining to the given trapezium, trapezium ABCD. Here we will get a parallelogram that is named as AEFD. First, we have to find out the area of this parallelogram. Here, first, a trapezium has base A, trapezium ABCD has base A, and the trapezium BEFC has base B. Therefore, here we are to considering area of the parallelogram ADEF. How can we considering? It is equal to area of the parallelogram ADFE. Now here it is equal to base into height. Here base equal to DC A and CF B. Therefore, the total length of the base is A plus B. A plus B into the height is taken as H. A plus B into H. Therefore, in this figure, the area of the parallelogram ADFE equal to base into height equal to A plus B into H. Now, let us consider the area of this trapezium ABCD only. How can we find out? This is the half of the area of the parallelogram ADFE. Therefore, area of trapezium ABCD equal to half of area of the parallelogram ADFE. That implies it is equal to half into area of ADFE, that is equal to A plus B into H. Therefore, here we have to find out the area of the trapezium. It is the half of the parallelogram, that is half of A plus B into H. Here A and B are two parallel sides. Next, we have to find out the area of rhombus. How can we define? That is, a rhombus is a special quadrilateral it has 4 equal sides and 4 angles. These 4 angles are not a 90 degree. 4 angles which are not 90 degree. If it is 90 degree, the quadrilateral will become a square. And opposite sides are parallel to each other. Its diagonals are bisect each other at a right angle. Its diagonals bisect each other at right angle. That means it is 90 degree. Bisect each other at a right angle. That is, here it is a quadrilateral. It has 4 equal sides, and here the diagonals are bisect each other at 90 degree, and opposite sides are equal, but its angles are not 90 degree. If the angles are 90 degree, this quadrilateral will become a square. Let us consider the diagonal AC is D1 and BD is D2. Now here we have to find out the area of this quadrilateral, that is the area of the rhombus. Area of the rhombus equal to Here we have to find out the area of the triangle ABC. Here AC is the base and the height is taken as H1. First we have to considering area of triangle ABC plus area of triangle ADC. That is equal to, how can we find out? Here AC into height, base into height, half into base into height plus half into base, here same base AC into, here the height is taken as H2. That is equal to half into AC is the base, common base, AC into H1 plus H2. That is equal to half into AC is the diagonal. It is denoted by D1. And H1 plus H2 is the diagonal BD. That is into D2. That is equal to half into D1 D2. Area of the general quadrilateral, that is, here we are considering a quadrilateral A, B, C, D. We have to draw a diagonal AC. It is denoted by D. How can we find out the area of this quadrilateral? Here, when we draw a diagonal, we will get two triangles, triangle ADC and triangle ABC. Therefore, here we have to find out the area of the triangle ADC plus area of the triangle ABC. It will be equal to the area of the quadrilateral. Therefore, area of the quadrilateral equal to area of triangle ADC plus area of triangle ABC. That is equal to, here we have to considering, in the case of triangle ADC, H1 as the height. Therefore, area of the triangle ADC equal to half into, here AC is the base. Therefore, AC into H1, height is H1 plus, then consider the triangle ABC. Here H2 as the height and the AC as the base. That is, both of them have common base AC. Therefore, area of the triangle ABC equal to half into AC into H2. Here we know that AC is the diagonal of the quadrilateral ABCD. Now here we have to consider half into D into H1 plus half into D into H2. That is equal to half into D into H1 plus H2. Therefore, the area of the general quadrilateral is equal to half into D into H1 plus H2.